So now let us come to appreciate the circuit breakers and what they are, what they do in our circuit. So circuit breaker, simply put, or the simple definition of a circuit breaker is that the circuit breaker is a switching device. It's a device, an electromechanical device that is designed for switching on or off your circuit on load. Are we getting it? So it is designed to switch on or off your circuit on load. Very important, because the circuit breakers, they are designed to handle whatever arc that will be formed during the switching on load, or that is during the opening or the breaking or making of your circuit while the circuit is on load. So that is what the circuit breaker is. So, and that is what you are seeing on your screen now. So this is the modeled case circuit breaker, and this is the miniature circuit breaker. So we are going to look in details what are the components inside of these circuit breakers, and how these components interact with one another to cause the normal operations of this circuit breaker when there is a fault condition, okay, that is expected for it to act. So put it at the back of your mind. Circuit breaker is meant for switching the circuit, that is making or breaking the circuit while on load. That is the function of the circuit breaker. So as you can see on your screen now, these are the symbols, okay, of the circuit breaker, and this is how they are represented in electrical diagrams. Okay, so this one that you see on this particular one is denoting or depicting those fixed mount circuit breakers. Okay, those breakers that are permanently installed in the circuit or in the cabinet. Okay, then this, you see the symbol of the circuit breaker followed by a double arrow up and down. Okay, so these double arrows tells us clearly that this is a detachable circuit breaker, or a draw out circuit breaker that you can actually rack out of the circuit. So when you see this symbol, that tells you that that circuit breaker in that particular circuitry could be racked out. So apart from these two, the device numbering can also be used to represent the circuit breakers in electrical diagrams. So the device numbering for circuit breakers is 52. Okay, as you can see. So this represents also a circuit breaker. So when you see 52 in the box like this in your electrical diagram, that tells you that what you are looking at is the circuit breaker. And of course, this double arrow following each other up and down tells us that this is also a detachable, okay, circuit breaker that you could rack out of the circuit or the cabinet. So the lower right, you will see this is an electronic circuit breaker. It's a modeled case circuit breaker. We will see how these electronic circuit breakers they function later. Okay, so we'll see the importance of these trip calls and how we can do the trip settings of this electronic circuit breaker. So let us look at the various classes of circuit breakers. Remember, we said for the purpose of this program, we are going to categorize the circuit breakers into two broad categories. Okay, that is the low voltage circuit breakers that operate within that is from 1, okay, to about 1,000 volts range. Okay, that operates within the voltage environment that is less than or equal to 1,000 volts. So those set of circuit breakers, they are referred to as the low voltage circuit breakers. So most of the miniature circuit breakers that you come across, in fact, all these miniature circuit breakers that you come across and most of the modeled case circuit breakers, they operate within this voltage environment. Okay, so now we also have the medium and high voltage circuit breakers. All of them are categorized as the high voltage circuit breakers. So these are the circuit breakers that operate within the voltage environment of above 1000. Okay, so those that operate within the voltage environment of between 1000 and say 70 kilovolts, that is 70,000 volts, those are medium voltage circuit breakers. Then above 70,000 kilovolts, they are the high voltage circuit breakers. So we are going to see how all of these circuit breakers they operate as we go along in this training. So on your screen now, what you are seeing, this is a medium voltage vacuum circuit breaker. So we'll see later what informed the naming of this circuit breaker. We'll see later what informed the naming of this circuit breaker as vacuum circuit breaker. So this is for medium voltage. And of course, if you look to the right, you will see the high voltage circuit breaker. Okay, so these are circuit breakers that operate in the voltage environment of above 70 kilovolts. So let us look at the low voltage circuit breakers now, and then we are going to look at the different operating mechanisms, okay, of these circuit breakers. So the low voltage circuit breakers can be further categorized as the thermal circuit breakers and the magnetic circuit breakers. Okay, so now when we say thermal circuit breakers, that means the trip element, okay, is controlled by heat, the heating effect of the load on the circuit, that is the current flowing through the circuit. Okay, as we'll see later, the tripping element is made up of bimetallic strip. Okay, we'll describe the bimetallic strip to us later. So that bimetallic strip, once it is heated, it will bend. Okay, we'll know the heating effect of current. As the current is flowing through the conductor, I square arrow effect. Okay, so as I is increasing, the I square arrow, that is the heat dissipated, is also increasing. So as it's increasing, it will increase to a stage that it will cause the bending of that bimetallic strip. We'll come to see it later. So this is a symbol of thermally operated circuit breakers. So you can see the thermal element represented by what you are seeing on your screen now. And this is the circuit breaker. So if you see it like this, it shows clearly that what you are looking at is a thermal circuit breaker. So here also is how it is represented. This is the NEMA representation of the circuit breaker, the thermal element of the circuit breaker. This is the IEC representation. So here we have some examples of the circuit breaker, which I believe you are familiar with. Okay, that uses thermal and magnetic element to control the tripping of the circuit breakers in the event of a fault. We'll come to see all of those later. Then the other category of the low voltage circuit breakers that we will be looking at are those that are controlled magnetically. Okay, so you know, on the thermal element, there must be some time delay for the bimetallic strip or the heating element to get heated up to the extent that it cannot cause the bimetallic strip to bend. So that amount of time that is needed, a lot of things can happen, especially when we have fault currents like short circuit currents that are intense, that are more than 10 times the rated current, okay, that is supposed to flow through the circuitry. So if we allow such amount of current to flow through the circuit, even for a second, it can cause a lot of damage. So to avoid such, we need a tripping mechanism that will respond instantaneously when we have such condition in our circuit. So that is where the magnetic circuit breakers or the magnetic element, trip element, comes into play. So we know that every current carrying conductor have magnetic field around it, and the strength of that magnetic field, okay, the intensity of that magnetic field is determined by the magnitude of the current that is flowing through the conductor, which means that as the current is increasing, the strength of the magnetic field is also increasing. Okay, so we have, as we'll see later, we have a solenoid kind of arrangement such that when the magnetic field increases up the stage, an armature is either pulled or pushed, okay, that will later activate the tripping mechanism. All of this will be explained later. So these are the two different types of operating mechanism that we will find in the low voltage circuit breaker. So as you see on the right, this is how the magnetic trip element in the circuit breaker is represented. This is the circuit breaker also. So what we have here is the magnetic circuit breakers, okay, or the magnetic circuit breaker. This is the symbol, and this is how you see it in your electrical diagrams. So let us see how this thermal and magnetic circuit breaker, how they operate or how they actually work. So this is an opened miniature circuit breaker. But before we go into this, let us explain in a little bit detail, okay, how the thermal circuit breaker function and how the magnetic circuit breaker also function. So here, what you are seeing on your screen shows the thermal element is a bimetallic strip, as we earlier explained. So bimetallic strip is a strip of metal, okay, that is made up of two dissimilar metal, two different kind of metal that are joined together in the middle, as you can see. So since there are two different type of metal, assuming you are joining aluminum and zinc, you know that both metals, they have different rates of that they have different thermal expansivity, okay, which means that they respond differently to the same amount of heat. So let's assume that the one above have the higher thermal expansivity, while the one below have the lower thermal expansivity. So as you load these circuits and assume that the contact is closed, okay, when you load the circuit, the current will flow through from your line side, okay, to your load. Okay, so as the current is increasing, what happens? I square R effect comes in, since there is a level of resistance in this bimetallic strip. So that I square R effect, okay, we start heating up this strip. So as the load is increasing, you are increasing the load, the amount of current that is flowing through the circuit is also increasing. That will also increase the amount of heat dissipated on the bimetallic strip. So remember, both of them have different thermal rate of expansion. Are we getting it? So we have just assumed that the one up have the highest rate of expansion, which means that the one up will expand faster than the one down, okay? Which means this one will elongate faster than this one. And that will cause, since this one is going faster, it will cause the bimetallic strip to bend downwards, okay? And as it's bending downwards, it will open up the circuit, and then the circuit will trip. So that is how the thermal element helps to open up the circuit breaker, okay? So we'll come to explain it in the miniature circuit breaker as we go along. Then the magnetic circuit breaker, you can see this is the armature, okay? And this is the winding. This is the winding on the miniature circuit breaker, okay? That is what is represented here now. Okay, so as we have explained before, when the current that is flowing through this winding is increasing, the magnetic field will also be increasing. So it will increase to a stage that it will now attract this armature and then open up your circuit. Okay, so once the circuit is open up, there will not be a continuous flow from your line side again to your load. So when you look at these two elements, you see that they are connected in line, or rather a series, okay, with your load. Are we getting it? Good. So now let us now look at the open miniature circuit breaker and try to identify these two elements, strip elements within the circuit breaker. So this is the line side here that is attached to the incoming line, okay, the incoming power supply, okay, into your circuitry. This is the line side, and then this is the contact. We have the fixed contact and the movable contact, okay. So when this is closed, you see that current will flow from your line side through this contact, through the contact, this metal that is part of the contact, through this conductor, through this coil, okay, and then through this conductor also, and then through this bimetallic strip, and then to your load. So here we have this as your your magnetic trip coil, okay. This is the magnetic element of the circuit breaker, and here we have the bimetallic strip. Here, as we have identified before, this is the contact of the circuit breaker, and here we have the arc chute, that is the part that helps to quench whatever arc that is generated, okay, while opening or making the circuit on load, okay. And this is the reason why the circuit breaker is called a circuit breaker, and it is the reason why it can make or break the circuit while on load. This arc quenching, this device that helps it to quench the arc, okay. We'll come to see how it operates later, because once as it's opening or closing, the arc that is formed is pushed into this arc chute, which later will break the arc into smaller segments, okay, that is less powerful than the main arc, and that will help to extinguish the arc. So this is the magnetic coil as we identified before, and this is the bimetallic strip, okay. It functions the same way as this, but the arrangement is a bit different. We'll see that later. And then this is the trip mechanism, okay. So that is why it is called electromechanical tripping device, okay. Electromechanical device that is meant for switching your circuit on load, okay. So now if you look at this trip mechanism, when you switch on the breaker, that will help to close this contact, okay. So once this contact is closed, you see that this latch will move to this other slot for holding this latch, okay. This is the trip latch. Now look at the bimetallic strip. So now you have assumed that it is closed. So when you, let's assume that this particular circuit breaker is rated 10 amps. It means that anything above 10 amps, it will be seeing it as an overload, okay. So when you are loading the circuit, of course, current will be flowing through all of these internal components or elements through to your load. Are we getting it? So as it is increasing, the amount of current that is flowing through will also be increasing. And then from that I square arrow effect, this bimetallic strip, which is the timer element, will be heated up, okay. So look at this end, you see that it is fixed. So as it's being heated up, you see it will bend, and then it will bend and push on this strip mechanism. And once it pushes on it, you see that here will move up and here will move down, and then this latch will be released and the circuit breaker will trip, and this will open up. Okay, so that is how it takes care of the overload element. But remember, there we need a time lapse for the strip to get heated up. Okay, so the drawback is that if you have only this kind of tripping mechanism in your circuit breaker, when there is an instantaneous, there is an overcurrent, okay, fault current that comes into the circuit. Before this will get heated up, all other devices downstream will have been destroyed. Even upstream will have been destroyed, okay? Like the cable and the particular equipment that you want to protect. So now if you look at this now, you'll see that it cannot function to take care of such condition because of the time lapse that is needed for it to get heated up and bend, okay? That is where the magnetic trip mechanism comes into play. So remember that this is a current carrying conductor. Magnetic field is created around it. So when the magnetic field increases, you see this is the armature. It runs down to the under here. Okay, it's like a plunger. If you are familiar with the operations of solenoid, okay, so it's like a solenoid. So once the magnetic field passes, the field strength passes a level by virtue of the current that is flowing through the circuit, that will now pull this plunger, which is the armature of the circuit, and that will push this lash mechanism, okay, to push it down. And as it pushes down, that will help to release this lash. Remember, it will be here to help to release this lash, and that will cause the tripping, instantaneous tripping of the circuit breaker. So you see that because of this magnetic device that we have in this miniature circuit breaker, once there is an overcurrent, like short circuit current, okay, not overload now, you see that it will just trip instantaneously. Are we getting it? As it sees it, the magnetic strength will be strong enough to push this and then release the lash, and then the breaker will trip. So a combination of this makes the breaker to be complete. So most of the breakers that you will come across, especially the miniature circuit breaker, even the molded case circuit breaker, they have both elements in them. And that is why they are referred to as the thermomagnetic circuit breaker. So, okay, so like this one now is called a thermomagnetic circuit breaker because we have both operating elements in them. So that is what we have here now. Okay, this is the circuit breaker. So you see the symbol in front of the circuit breaker. So when you are going to buy or select a circuit breaker, if you actually need to have both protection in your circuit, the one that can trip instantaneously in case of heavy current, of course, you want it to have both tripping mechanism. So that is what we have here now. Okay, so this tells us that we have both the thermal and the magnetic element in these circuit breakers.